Hi, I'm Rosie. I was the 2021 Geo intern with GeoTenerife, and I've been working on a volcano that erupted in Palma in 2021 with GeoTenerife and the University of Cambridge, where I'm studying for my undergraduate degree. The Canary Islands have experienced highly explosive and prolonged eruptions during their evolution, as well as less explosive eruptions in historical times, particularly on Tenerife, Lanzarote, El Hierro and La Palma. The 2021 eruption in Cumbre Vieja provides a unique opportunity to study a fresh eruption in deep detail. The life cycle of a volcano is a bit like that of human beings. First comes the incubation period. In this case, a series of anomalous signals announced that the Cumbre Vieja system was reactivating years before it actually erupted. Magma, which is a name given to melted rock containing crystals and gases beneath the Earth, can send signals to the surface as it moves around. Scientists monitoring water and gas chemistry near the eruption site noticed unusually high rates of helium, which was interpreted as a silent magma movement deep in the Earth's mantle between 2007 and 2017. In 2017, clearer precursory signals appeared. Hydrogen, a typical gas species found at high pressure in magma, was silently released into the atmosphere 15 times more than its usual amount in this area. Then, in October that year, the first series of anomalous earthquakes shook the ground at 15 to 30 kilometers depth. These short bursts of seismic activity, or seismic swarms as they are called, were repeated 9 times until 2021. Crucially, there were other indicators pointing to a reactivation, with rising hydrogen and carbon dioxide being silently degassed at the surface and measured by scientists. Throughout this period, magma was stored 8 to 10 kilometers below the surface, but it was still struggling to escape, so there was no eruption yet. But imagine shaking a bottle of soda. You can do it a few times, but eventually, if the pressure builds up enough, the bottle explodes. It's the same with volcanoes. This gestation phase of the eruption entered a path of no return on the 11th of September 2021, and the volcano went into labour. Intense earthquakes beginning at 10 kilometers depth quickly became shallower and rose to the surface as magma broke through the fragile underground rocks. Simultaneously, the ground around the volcano pushed up and deformed at 15 centimetres. These are 2 clear warning signals that an eruption is imminent. On the 19th of September, after a large earthquake in the morning, followed by a period of calm, the eruption finally began with an audible roar. The birth of La Palma's latest volcano was recorded at 10 past 2 p.m. at a place called Cabeza de Vaca. It was a son of Cumbre Vieja, on the southern ridge of the island of La Palma. Like most of the eruptions in the last 500 years or so in La Palma, the magma that rose up to the surface didn't emerge from an older cone, but formed its own arrangement of vents along a crack trending northwest, at an altitude between 800 and 1,100 metres above the sea. This is what is known as a fissure eruption. The first few days of volcanic activity were characterised by the emission of lava and low-intensity explosive eruptions, ejecting ash and molten fragments rhythmically. These eruptions are called strombolian, resembling the activity of the Italian volcano. They are typically hot and fluid magmas with poor gas content. During the period of the volcano's infancy, lava flows advance downslope up to 700 metres an hour. These rivers of rugged, incandescent rock at more than 1,000 degrees Celsius were internally pushed by the semi-molten mass of magma. At the front of the lava flows, tens of metres thick, rapidly cooled fragments fall down and are ingested again by the advancing hot mass. It's a bit like the movement of a caterpillar tank. In these early days, the Strombolian activity of low-intensity eruptions of ash and molten lava was interspersed with dramatic events called fire fountains, vertical curtains of lava up to 250 metres high that started piling up hot rocks, sculpting a small cone representing the youthful body of this baby volcano. The irregular cone resulting from the spatially disseminated volcanic activity grew rapidly several metres every day. But because it was building up on inclined surface that was very unstable, by the 25th of September, the western flank of the growing cone partially collapsed under the power of gravity and the fleeing lavas. A massive fragment of the cone was rafted away, leaving behind a breached silhouette. But volcanoes are born to fight against all other forces of nature, and the intense activity rapidly regenerated the edifice. As the volcano entered its youth, there was a change in the earthquake pattern. In early October, new events larger than 4 in magnitude appeared at depths between 15 and 30 kilometres. Presumably, the rapid emptying of magma from its reservoir sank and stretched the roots of the volcano. Consequently, the activity became more variable, with periods of intense fire fountaining and Strombolian explosions mixed with periods of ashy columns and predominant degassing. Lava was constantly released from the lower vents of the cone at rates higher than 50 cubic metres per second. But this time, it was hotter and more fluid than before. As a result, lava flows drained using channels near the cone, before expanding laterally at greater distances. Flows extended to the cliffs near the ocean, flowing and rolling down to form extensive platforms of fresh volcanic lands off the coast. Once they reached the sea, the lava flows were quickly quenched by the water and vigorous steam columns of corrosive and toxic gases emerged. By mid-November, the cone reached 180 metres high, and nearly 23 million cubic metres of ash and rock fragments had fallen from the air. At this mature stage of its formation, the activity alternated. There were some periods of pure degassing, but at other times, rainfall water infiltrated the cone and caused explosions of abundant steam and fine ash, a style of activity known as phreatomagmatic. While most of the lava continued to escape from the western flank of the volcano, other new vents opened towards the east and southeast, producing more ash and new lava flows. These continued piling up downslope to form accumulations reaching tens of meters thick and covering almost 12 square kilometers by early December. The adult cone finally reached over 210 meters high, and its last gas formed a tall vertical column 8 kilometers high on the 13th of December. This explosion ejected big rock fragments for hours before the deathly silence that marked its end. On Christmas Day, 2021, the eruption was officially declared to have ended by the 13th of December. But the large Cumbre Vieja ridge is far from being extinct. It has returned to a deep sleep. This latest eruption has been by far the longest, most explosive, and volumetrically significant in terms of lava output of the last 500 years. We can learn a lot about the evolution of volcanic islands and their eruptive behaviour by studying this recent eruption. Palma has seen 3 volcanic eruptions in a generation, in 1949, 1971, and now in 2021. Other islands have also seen recent volcanic activity. In 2011, there was an underwater eruption in Tagoro volcano, El Hierro Island, and a volcano called Chingero erupted in Tenerife in 1909. All of them had pretty much the same profile. We still cannot predict the exact date, time, and location of an eruption. But what is being learned from this latest eruption will help scientists to keep monitoring these beautiful Canary Islands so that we can understand them better and build resilience for any future event.